everybody, and welcome to Limawi. Welcome, not to Limawi, but welcome in the Limawi channel. Tonight we'll talk about Wireguard and Ansible. We basically will continue the Ansible collection we started, or at least we continued on the last stream. And tonight we will do something new with it. So, without further ado, let's go back on the scene. So as you can see here, we have our deployment. It works. Actually, it works. The deployment works. So you can see that on the first run, it takes 575 seconds. So that means 300 plus nearly 10 minutes. No, 8 minutes. And afterwards, the subsequent runs take them roughly between 15 and 20 seconds. Yeah, 22 there. And the other one here, 18. Okay. So, as you can see, we have a deployment that deploys and is also idempotent. And why we do the test twice? Because between this idempotency and this one, the idea is that sometimes we try to mutate a bit the deployment. So change the parameters, something like that, to see how the system reacts, the deployment reacts to that. So that's it. We finished the rule. So end of the stream then. I will click on the button. No, of course not. Because there is something we didn't do. We didn't test our stuff. We don't know if it deploys correctly. We know that Ansible can deploy the stuff, but we don't know the result. We don't know if Wireguard works. We know that Ansible deployed a bunch of stuff, a bunch of things. We hope that's the things that at the end create our Wireguard mesh, but we don't know. So, tonight, in this stream, in this record for those of you who watch it on YouTube or whatever other website, Limawi for instance, tonight we will use a compliance policy tool called cnspec that will be in charge of executing tests that we will write, tests that will try to demonstrate, to prove that our system works. Actually, cnspec is a very recent tool. I think the first commit is not even a year old. So we see here, the first commit is from, there are 300, nearly 400 of them, so I won't do that. But the first commit, if I remember, good frequency, no commit, sorry. Yeah, it's not even a year old, but we don't care. We will test it. cnspec was created by Mondu, as you can see on the GitHub repository here. And Mondu was co-founded by Chris Rock and Dominic Richter, if I remember correctly. And they, yes, so you see, actually, yeah, it was made open source in September because I worked with Chris Rock on another project called devsec.io that was also a project that created profiles for testing infrastructure with a tool that was called inspec. And inspec is actually the predecessor of cnspec in the philosophy, at least. That cnspec is written in Go, inspec was still maintained in Ruby, and inspec was more targeted towards legacy systems, and cnspec pretends to test the same way legacy systems, cloud, Kubernetes stuff, etc., etc. So that's why we try to use cnspec. Full disclosure, I already used cnspec for other projects, but these projects were mainly based on Terraform. And in our case, it's Ansible with Vagrant, and that's the first time I will do that. So, we'll see. So first, clean the environment. So basically, we destroy the virtual machines with Vagrant. If I don't do too much typo, it should work. Wireguard Ubuntu bats, because we use the test tool bats. I think I will deprecate it as well, but currently we use this one. So, okay, the environment is clean. So, let's go towards the... what could it be? Where did I put this template? I don't quite remember. You reuse an old Ansible collection that was actually at the beginning targeted to be a template, sort of. So that's why it's overcomplicated everywhere, because I templated it for multiple use cases, and now I will try to really simplify it a lot. But for the time being, what we will do is to vampirize the test run bat script in order to try to install cnspec and run our cnspec stuff. So here is the line that runs the tests. So here we use bats, but in our case we will try to use cnspec. So idempotent C, okay. If test suite. So if, I don't know, test cnspec, let's go that way. Let me think. If we remove paths, if we use cnspec for everything, we first start with the local setup of cnspec. We won't try to go directly towards the remote repository call. So, in order to do that, we will call here, create here. But actually, we can't put it in the same directory as the molecule stuff. I think that will do the trick. Yeah. So, open project, molecule. So basically, we will remove that first. Then we call cnspec with a profile that should be in a cnspec directory in molecule directly. Yep. Okay, cnspec, and we use a profile. But first, we try to install cnspec itself, because it's not currently installed. Let's do that here. So our environment is Ubuntu based, so I suppose we could install basically their dev package, because they package something in deb. Okay. So wget, okay, and dpkg e. Am I sudo? I don't know. We'll see. Yep, here. And we'll clean that. Yeah. Okay. I will take care of the versions after. I will make that handleable by renovate, but for the first draft we'll stick to that. We'll see if we can install cnspec basically that way. Okay, we build the artifact, then we run the test suite. Wireguard, Ubuntu, pass. Does it work or not? So first, we create the 3 machines, Wireguard 1, Wireguard 2, Wireguard 3, and the provisioner. And inside the provisioner, we will provision actually our stuff. So, as we currently use vanilla Ubuntu Vagrant machines, it has every time to reprovision Docker, Docker Compose, and some other libraries. I know it's not idle. It's a waste of time, but I prefer to prioritize the Kubernetes setup before creating golden images to speed up everything. So, it also installs Snap. It's really Ubuntu. For those of you who, lucky you, do not know anything about Snap. Snap is the new package manager from Ubuntu, from Canonical. It's pure... Right, anyway. I prefer to stick to deb when we are in the Debian world. And of course, podman, Docker, containers afterwards. Anyway, I see that step by step, people are coming. Please take a seat and don't hesitate to ask questions in the chat. I will try to answer them with the best of my abilities, which is not very much. There is no stupid questions for people who do not have any clue about what I'm currently doing. I will try to answer as well. So I lost my thought. Where are we? Still installing stuff. I'm sorry, it takes a time. Every stream, I ask myself the same question: should I do the golden image first, and then postpone a bit the Kubernetes cluster? Then I see that to do the golden image, I should have a GitLab CI/CD with correct Livirt container integration, and so and so and so. And I tell to myself, if I want to have that, I should deploy GitLab through Helmchart on a kube cluster in order to link it to a KubeVirt and so and so. And at the end of the day, I told myself, maybe we should first create the Kubernetes cluster. So wget is not installed. Okay. Is curl installed? Curl is normally installed. Curl. I never remember the curl flags. Sorry, no memory. So curl download. Yeah, simply. Or curl download file. Curl download. Oh, no. Curl download file. Featuring web page, yes, but I want to download something. Yeah, curl. Oh. With the progress bar to be nice. Okay. I don't have any memory. I just know where to find stuff and what I want to find. That's all. And as I write everything in code, once it's written, I forget it. Because it's only implementation details. It's not important to remember that. So let's rebuild the artifact, and then let's redeploy that stuff. Maybe I have an example somewhere of the curl command inside my old code. Boom, boom, boom. Do I use it somewhere? Anyway. So once cnspec is installed, we'll use it. For that, we'll try to create a bundle. First locally. I don't remember if it's possible, but at least we'll stick to some files. And afterwards, when we start to have a lot of bundles, a lot of stuff, we try to put that remotely. So I'm interested in the integration with Ansible. I want to do a cnspec scan. But I saw, yeah, inventory file, yes. Okay, that's what I will use. So, the idea is, we install the cnspec binary. With the binary, we will call it with the inventory file flag. That way, the binary will understand that there is 3 other virtual machines to inspect. It will normally use, because it's an Ansible inventory file, and normally I didn't tweak too much the SSH client, but I will have to check that, but I think I didn't tweak it too much. So it will normally be able to access the 3 machines through the SSH client. We will check that, and if it's successful, then we will start to create the file and write the test. Basically, we write a test that we check that the interfaces are up, the NIC, the Wireguard NICs are up, and we will test afterwards that we will basically gather the packets and these interfaces and check the headers to see if the receiver and the senders are the other NICs from Wireguard and not another network interface. And once that's done and we checked that we have packets from every point to every point, we basically stop there because I think we will have our test. Ah, yes, no, there is maybe a test to check the cryptographic stuff. So to check what level of cryptography we have in Wireguard. But normally Wireguard can't start if it doesn't have an enough level of cryptography. I use an ED25519 cryptographic algorithm, so I think it's pretty okay. I think I wrote the wrong command. Yeah, I wrote the wrong command. So, destroy the environment. Hop là. Yeah, I wrote a wrong command. That didn't call the correct test suite. And I put it back up. Ah. So correct command this time. I should really rewrite it, but yeah, it's always this question of golden image or not. Because if I create the golden image, I won't need to write that. And in the golden image, I will write that completely correctly with the hash test. Keys test if, for instance, but I don't know if the public keys, signature keys. I don't think so. Do they publish hash? Yeah, they publish hash at least. So hash test. And everything installed in the golden image. Not a container, but an ISO image or whatever that can be installed through Vagrant. Why not a container? Because we need network interfaces to connect the provisioner to the other virtual machines. We actually need a good representation of a true virtual machine or a true hardware system. And the container cannot provide that completely. So that's why we stick to Vagrant and virtual machines. Because we do infra stuff. We do undercloud stuff. So the golden image, I think I will do it with Packer. And I will include everything in it. So that means that all these steps there that we wait for, I don't know, 5 minutes. And all these steps there won't be necessary anymore. Mm-hmm. Already 7.5. I really hope that we won't spend this stream trying to install CNSpec. If it's the case, I'm really sorry, and I should have installed it before. But if it's the case, in the next stream we will do the tests. Sorry. Maybe. Yeah. I just changed my my light to put my skin tone a bit towards the red. To make it a bit more cozy. Because it's a cozy stream. It's not an angry stream. Not in my nature. So we download the bats container. All this logic there should really be greatly simplified. Could not resolve proxy O. Curl. Curl. Do download and install deb packages. Really, this stream is a bit silly. They all use wget, but I don't want to install wget if I have curl. But I forgot the... oh, okay, simply that, okay. Okay. Yeah, it rings a bell. Put in. Destroy. Without forgetting a letter. All that just to install the deb package. Silly me. Okay, artifacts created. We launch everything. Quiet moment in the stream. That happens sometimes. It's a quiet stream. I'm just thinking about multiple things. That's all. Basically, I'm thinking about the architecture, because this time we waste there annoys me. But really, if I spend time building a golden image, I mean, the quality won't be there with the current tools. It goes for the updates, and so it will be a great hassle. So yeah, I'm just thinking. That happens sometimes. That's the living work of a platform engineer, platform architect. When we build stuff, sometimes it works, sometimes it doesn't. We have constraints on many things. Sometimes it's slow, sometimes it's fast. You have to make choices. Yep. For instance, my choice now is to sit. That's the choice of the moment. Okay. But yeah, I'm remanaging stuff. Maybe I should write a silly golden image for the provisioner and leave it that way, and prepare the tools and update it when the tools are there. Yeah, perhaps we should do that instead of wasting time like that. Yes, perhaps. Yeah, so I create the golden image. We do our tests until we have a Kubernetes ready. Once we have the Kubernetes ready, the Kubernetes cluster ready, we create one kube cluster. Inside, we deploy our GitLab. With GitLab, we create the correct workflow for the golden image. Then the correct workflow to test the kube cluster itself. CNspec is there. Okay. And once you have that, we can iterate on the kube cluster itself as well. Update it correctly. And once we have stabilized that, we can start to create other kube clusters with other domains, other contexts, and so on and so on. Yeah, perhaps we should do that way. It should be more efficient. Yeah. Yeah, we take the Ubuntu base image, we put our libraries inside, we snapshot that to create our golden image. And with Vagrant, we can call a local image. And we can do that. Perhaps. Yes, perhaps. We update it manually at first, this golden image. And once we have a GitLab ready, on the kube cluster with the correct code to kubevirt, then we test it through. We create a correct Packer definition. We put it in a GitLab custom repository because I think currently GitLab does not support a specific repository for golden image, but it supports custom repositories with custom stuff in it, custom archives in it. So we put it there. And from the kube cluster pipeline, test pipeline, we call this new one, this new golden image. Yeah, it's maybe more efficient. Yeah, should replan that then. Because basically there, we did, what, 4, 5 run, where we could have done a dozen, 20 runs, because of this silly installation at the beginning. I mean, it takes so much time, because the really interesting part starts here, actually. When we are here, that's the really interesting part. Because here we really start to test the stuff. Here we are currently deploying Wireguard. So what this test is supposed to do, we are currently doing it here. And not before. So, I always do, when I have a cluster system, I always do a deployment by thirds. So, in our case, we had 3 nodes, so it's one after the other. But if we had 6 nodes, for instance, it would be 2 after 2, and 9 nodes, 3 after 3, and so on. So, deployment by thirds. Why? Because that way I'm always certain that if something goes wrong, then the rest of the cluster is not impaired. It would be even better when we reach prod to do a deployment by fifths instead of thirds, by fifths. So every 5, you know. Because in that case, we always keep a margin. If something goes wrong, we always keep a margin to repair before being completely blocked because the decorum is in jeopardy. Because at 2, the decorum is not in a very good state. At 4, we can cut the 4th node or the 4th part and be at the 3 nodes cluster or 3 parts cluster. That is the correct quorum. At 3, if something goes wrong, we are directly at 2, which is not very good. But for test there, I mean, we are not in prod. So let's stick to 3. But that means that the resulting Kubernetes cluster will have at least 5 virtual machines for satellites. Satellites, that means core DNS, BGP, etcd. That will be the satellites of the kube cluster. etcd because it's the memory of the kube cluster and it should not be installed in the same nodes as the kube masters for resiliency. Core DNS is there to do the very first DNS that will provide a way. Actually, I have a colleague that can explain that to you, maybe in the next stream, or I don't know, in a future stream, I could call him and he will try to explain that to you. The idea is that we have Kubernetes stuff that need a correct certificate. And in order to do that, it sends a CSR to approver inside the kube cluster. So an auto approver added to the certificate authority inside the cluster. And this approver needs multiple checks to be sure that the kubelet is really what it is supposed to be and not a rogue one that tries to impersonate a correct one. And one of these tests is to have a DNS record somewhere that could correlate the IP of this kubelet with its host name or FQDN written in the CSR. So for that we need DNS somewhere that is able to do the conversion. So that's why we need these core DNS. I created a role for bind9, but I'm not sure. I think core DNS would be better suited for that. So that's why we need a core DNS pod. It will be basically a kube file, but run by podman that could create these records and distribute these records inside the Wireguard mesh. Because Wireguard will provide a set of IPs, and core DNS will provide the translations between these IPs and the FQDNs. So I talked about etcd, core DNS, and the third one, which is BGP. In our case, it will be Bird. It's already the case. It works already. For those of you who watch the streams in French, you saw it working already. So Bird, which basically creates BGP routes between the masters, between the kube masters, because that way it provides the external load balancer of the kube cluster through virtual IPs. And even with KubeVIP, which is the implementation related to this BGP, we can even use afterwards the core DNS to provide a failover through DNS. So that's the third satellite. And afterwards, we have the kube cluster itself. And that will provide a completely detached kube cluster, completely detached from any cloud solution, running only with open source stuff, and that you can install absolutely everywhere. According that the OS that runs on the machines is currently Ubuntu, but later we do also Flatcar Linux flavor. Okay. Now that the deployment is done, I will run a terminal, go inside the project directory, and start tweaking the cnspec call in order to make it work. So,
error, unknown command. Yeah, I know. It's a silly command. Ah, shit, it stopped the container. Ah, I shouldn't have done that. So, that's this silly command that is completely wrong. But I know it's on purpose. But what I will do instead is sleep for an hour. I will redeploy and check the documentation on how to call it correctly. There. So we clean the environment. Okay, done. Recreate the artifact, but normally that part should not be affected. But we're never sure. And we redeploy. And meanwhile, I will check the doc just to see how to call that stuff. So basically, if I look at the doc, where is it? Here. So we close that, then let's not be lost in the tabs. So we have an Ansible. Ah, yeah, but Ansible is not installed in the same machine. Maybe this flag works. So, in order to call, and you will see the silliness of the current setup, in order to call the environment and everything inside, you have to execute that. Because, so let me just show you why. We have currently a global container that contains a Vagrant command that is tied to a libvirt, so to a virt hypervisor, KVM hypervisor. This Vagrant command then creates the machines. So, in order to access the insides of the machines, we have to use Vagrant SSH to drill the tunnel, go inside the machine through SSH. And that's then that we can start to write commands inside the machine. So you see the complexity of the stuff. So in our case, we have to do WG1, for instance. No, sorry. No, it's on the provisional one, so that's not the correct one. So, in that case specifically, we don't need to go inside the Vagrant SSH connection. We can stay on the... No, we have to go into the provisioner itself. So I'm lost myself in my own stuff. So see, I really need to simplify that. Okay. Then here we should do an ls to see if everything works correctly. Yes, we are inside the correct provisioner. cnspec is not installed yet, but as soon as it's installed, we do a cnspec help to see if it works correctly.
And then we'll try to gather the inventory from inside the virtual machine and check if cnspec can do something with that. Yeah, we lose so much time to rebuild the environment every time. Yeah, I think I will do the golden image. A silly one, but I will do a golden image. That will be maybe for the next stream or between streams. A quiet moment. Actually, is it installed? Yeah, I think it's installed before. No, it's not. It's installed after, or is it failing? Ah, it's installed after. No, it should be there. What's happening? Ah! Oh, that will be... Okay, how can we do that? Because I understood the problem. Actually, it's not installed in the provision itself. It's installed inside
Oof. Inside the container itself that runs.
Ansible.
So, pum pum pum, pum pum pum. How can I do that way? Yes, maybe.
Not even
Sure, we'll see.
See and spank. Doo-doo-doo.
Ah, oh, oof, Okay, inside.
Okay, yes.
Permission denied. Ah, yeah, should be sudo. I think I can sudo right away. Yes! Woo! Perfect. I mean, actually, it's completely silly. It's I really have to change that, but it's perfect.
Docker exec. Yeah, we have it.
So, we have our C and spec binary.
And now
We need to call it
we scan and the inventory file. Other quest,
trying to find.
the inventory.
So, where
In my silly setup, in my silly
thing, where did I put the inventory file? How do I mount it? Sometimes it's hard to be me. Ah. Is it in?
Yeah, I think normally it should be into user local
SRC.
Yeah, there is the artifacts folder. Yeah, there is an inventory here. Oh, actually, it's simple. It's a very simple setup. I don't know where the problem is.
Then
We will wait for the deployment to be finished before running cnspec scan, to be sure.
sorry. It's nearly finished. And then we will be able to test the cnspec scan command. Ooh. It takes so much time anyway. Sorry. It's a bit stuck there. Ah. It listens to me. Good. So the first deployment is done in 10 minutes actually. 600 seconds. $22 seconds. Yeah. Okay. So now we have the sleep for 1 hour. So let's test. Unsupported backend. Cannot return shame for backend. Yeah. Because we did a scan without a file, a policy file. So first thing first. If we can do a run, maybe? Is it a run? What is it to discover stuff? No, it's not run. shell maybe? Ah, yeah, I think it's shell. Does shell takes the inventory command? Is it done through SSH? Hmm. So maybe we will create a dummy scan. Okay. With a policy bundle of, I don't know, nothing. Let's first try this one. Ensemble inventory. We take the inventory. Then we pipe. Ah! Does the pipe break? I'm not even sure. It's possible that the pipe breaks everything. We'll see. Up. Yeah. The pipe breaks everything because the pipe ejects the command outside the context of the container. Maybe by doing so. Docker exec. Shit. Wait. What does the inventory Ansible flag takes? CN spec. No, it goes directly on the Ansible website. CN spec. Ansible flag. 2 issues, no code. Ugh. So let's go back to the one that was less broken. Okay. Cannot return scheme for backend. Backend unknown. Backend unknown. Can we force the backend? Well, but that normally it should detect it. Maybe it's the file. No. It's not really interesting, is it? No. Let's call a dummy policy file. Up. I could not load policy bundle, so is the inventory file wrongly written? No. We have our notes. Why doesn't it detect the backend? Is it my all complexity stuff that screwed the backend? It's possible. Yes, because I call SSH in a weird way inside the container. Because the container actually created this container containing OpenSSH client and Ansible, and I made the container with the floating UID, you know, a UID that you can set and run. So for that I had to tweak OpenSSH client because OpenSSH client doesn't work by default with the floating UID. But maybe it broke so many stuff, so many things. So yeah, I think it's a part of the rewriting I should do. So anyway, we have in cnspec that is installed, we have the possibility to call the inventory file. But due to the complexity of my current installment, I think my first step should be to greatly simplify all that, because it's too complex. So there are border effects everywhere now. So I think that will be a shorter stream for today. Because I think we can't really go further without hitting many border effects. So sorry, but you saw the Wireguard deployment work at least. But for the next one, if I have time during the week, I will try to simplify everything. And for the next one, either we continue simplifying or I have finished simplifying and we can go back on testing our stuff with a cnspec CLI scan. So, in that case, I wish you a nice evening and we see each other next Wednesday for the recording. Bye bye. See you next video.